Gravity filtration doesn't necessarily tell you much about a mixture or a compound, but it will help you to further purify it. When you pour the mixture through the filter paper, the insoluble impurities will be caught and left behind. You still may have to use more techniques to further purify your mixture though, depending on what you're doing. Suction filtration, like gravity filtration, won't tell you much about the molecule, but it will help purify it. You can pour your compound into there and all of the liquid will be sucked out of it and you'll be left with just your pure crystal or compound solid. Once again, I talked about rotary evaporator earlier in one of the questions, but the rotary evaporator can be used to purify a mixture by removing the solvent from the mixture, so you are just left with your desired product afterwards. Drying agents can be used to purify a compound. We used it in the liquid-liquid separation to remove excess water that would be contaminating our product. They don't necessarily tell you anything, they just purify your compound. An IR spectrum basically shows you the functional groups that are inside of your molecule. It can be used to identify a compound or assess its purity. The purity can be assessed by comparing your experimental IR to a literature value of the IR. If there are other functional groups that should not be in the IR, then obviously your compound has been contaminated. The identity can be found by comparing, once again, the literature values of different IRs to your experimental one and finding the one that matches up fairly closely. Simple distillation can be used to assess purity and identity of a compound. So for identification, you would boil out your substance and record the boiling point, then compare it to the literature value. If your boiling point is lower or higher than the literature value, then that suggests contamination. It can also be used to purify compound, because if you are boiling out the solvent, then the substance left behind will be more pure without the solvent, of course. And then also, if you were using it to boil out your actual product, your substance, then whatever is boiled out should be more pure than what it was before you boiled out all the impurities that are left behind. Gas chromatography can be used in a similar way as thin layer chromatography, because it once again has a mobile and a stationary phase. So each individual molecule, will have its own retention time that it takes to move through the mobile phase. So you can use this time to identify to a compound, either if you have an unknown and compare it to that, or maybe a literature value, but it has to be at the exact same conditions, which is sometimes tough to replicate. Liquid-liquid separation can be used to separate two liquids that are in a mixture that you don't want to have together anymore. It can also be used to purify compounds by the processes of washing and extraction that we talked a lot about earlier, so I won't go into depth now. But this purification is very important because you can later use these purified compounds to run other tests, such as melting point determination or TLC, and this will tell you more about your compound, and it can be used to do things like identify the compound. Recrystallization, put very simply, is dissolving your solid into a solvent and then later precipitating it out. It is used to purify a solid by removing all of the impurities that you do not want in your final product. Experimental melting point range can be used to identify a compound by using your experimental melting point range and comparing it to a literature melting point range. If they are the same, then they may be the same compound. It can also be used to assess purity. If your melting point range is lower than the literature value or broader, then it means that you either heated it too fast or it's contaminated. If it's higher, that means that there was probably poor packing of your capillary tubes. TLC can be used to monitor the progress of a reaction. It can also be used to assess the purity of a compound. In the left lane and the right lane, there should only be one spot, and in the middle there should be two in the close spot. If there's any more than that, then that suggests there's contamination of your product. It can also be used for identification by the retention factor. RF is the distance the compound travels from the origin, which is the dotted line, compared to the distance that the solvent travels. Under a specific set of conditions, they all have their own retention factors. So if you compare two retention factors of different molecules and they match up, then they should ideally be the same substance.